Okay, perfect. Hello, everybody. Welcome to a new session. This session is going to be packed with a lot of information. So we're going to try to go through all this information in a nice pace. But at the end, I'm going to open mics and you can keep asking on the Discord channel. We have a section for questions. So as I talk, you can write your questions. But either way, at the end, I'm going to open mics for anybody that actually want to speak up and ask your question in more details. So now let's start with these first 20 minutes. I'm going to go through some really nice topics that are going to really important for us to keep on building with Midnight and writing smart contracts. So this first section is going to be divided on education, diaries, and hackathon. First, let's check the education material that I have for you guys. We're going to talk about some cryptographic foundations, hashing, public key cryptography, and digital signatures. So these topics are really important, and I've made a summary for you guys. But just to give you the whole context, I'm grabbing all this information from the 8 modules that were released by the Midnight core team. There are going to be actually 8 modules in total. So far, there's been 5 modules released, and we just finished the last session, the first module, and now we're gonna take a look at the second module. So if we get into the second module, here they start by explaining some cryptographic foundation. So we're gonna learn about these topics. For that, I made this summary to explain these key concepts. One, it's hashing. Hashing in blockchain, it's everywhere. So what is hashing? It pretty much converts input data into a fixed size string. Why it matters? Because any small change that happens on the input, it's gonna turn out to be huge at the output. So it's for example, in addresses, we see that it's hashes from something of the blockchain itself. I made this graph to make this clear how it works. So we have some input data. Sometimes we have some salt, and then we apply this function, and we get this output, fixed size. From this output, we cannot go back. So you need to know this input to be able to calculate this hash. So that's why it's really important, and it allows us to do a lot of integrity checks. So here are some uses in Midnight where we use hashes. Ensure data integrity, prevents tampering, stores document fingerprints, and combines randomness salt to protect against guessing attacks. Another topic, it's public key cryptography. Again, it's all over blockchain, right? So how it works? We have 2 keys. One it's called the private key, and the other one it's called the private key and the public key. So the way it works, it's for authentication. So let's see here at the end the graph. Let's say you have your private key, and then you sign a transaction, and somebody else can verify that you actually signed that transaction just by knowing your public key. So public key is something that you share, and private key it's yours, nobody else knows, but you can do something with this private key to prove that you own something. So see how this relates to blockchain? And another important topic is digital signatures, which is pretty much one of the use cases of this public and private key. So we can see that Alice has a transaction. She signed the transaction with her private key, and then she broadcast the transaction to the network. And then the nodes, they can verify that actually Alice was the person who signed the transaction, and then the node can authorize to execute whatever was specified within the transaction. So we're going to go through all these important topics as we write smart contracts, but it's important to just create first the foundations. So when you see those terms, you're like, okay, I know what it means, right? Perfect. Having that aside, let's go to some diaries, right? We were studying the academy we were taking a look at blogs, but there's other material, which is diaries. So if you see here at the docs, we have the academy, and then we have dev diaries. How these diaries compare to blogs? Blogs, it's more like a general context of what's going on with Midnight. And diaries, they go more into details. It's more technical about instances or topics that we should know to write smart contracts. So they have already released a ton of dev diaries, but we're going to start at the beginning and we're going to catch up as we go with the sessions. So this first diary, it's regarding the Midnight indexer. We have already talked about the new indexer. So this diary, they explain what's new with this indexer that we nowadays we're using everybody, right? The previous indexer, it's not available anymore. So everybody that wants to use indexers in Midnight right now is going to use this new version. So here, when they released the indexer, they mentioned some of the key improvements over the legacy indexer. So they mentioned it's rewritten in Rust for improved speed, modular architecture. So this is something that we don't see, but once the modularity it's built within the foundations, it allows for flexibility and faster development. So now they're using this architecture, modular instead of the monolithic. And then they have a deep integration with all the wallet tooling. And when I say wallet, I mean the SDK and the Lace wallet. And also they say flexible GraphQL API with subscription support for real-time updates. So this indexer, it has all the batteries included that we need to actually build responsive applications. We can subscribe using the GraphQL algorithm protocol, and also it allows us to subscribe to events. So we don't need to be refreshing our page every time something changes on the smart contract. Actually, the indexer is going to let us know that something changed, and on our UI, our platform, that change is going to happen automatically. So yeah, that's a huge plus for the indexer. And for hackathons, today it's the last day. So anybody that it's been building or want to present something during the hackathon, today is the last day. So just gonna show you again how to subscribe. If you go to Midnight, then under developers, you have these hackathons, and here you're gonna have the option to register. So again, today is the last day. Go ahead and run if you haven't done so yet. Okay, so this is about the ecosystem updates. Let's now go into the technical part. There is a lot of topics that we're going to go through. We're going to try to cover most of them. In case we don't have time, we will continue on the next session. So we're going to learn how to see what are the new releases, right? The Midnight documentations and instances, they're changing all the time. So we have to look really close when those changes happen to see the releases changes and then update our code. So now they just released 3 instances or 3 languages. And I'm going to teach you guys how to actually look at those changes and all the things that we have to change after these releases are made. So first, let's take a look at the compiler and language release. They just released version 0.24 and 0.16. One doubt that people have is what is the difference between the compact compiler and the language? The compact compiler, as the name says, it's who performs the compilation. It passes the DSL, compact DSL, to JavaScript. And the language is the syntaxis, how we write our compact code. So let's take a look at this release. If we go to the docs, we have a tab here that says release changes. And under these release changes, we go to the compact compiler, and then here it says release 0.24. When that happened? June 11. So it was 2 days ago. Here they provide a quick summary that we can take a look at. But if we want more details, we just have to click on this release section. If we click at this, it's going to open all the release documentation. And we can go through all the documentation this new release it's about. But we can take a look at, as we learned, we haven't seen yet all these techniques to write smart contracts. In future sessions, we're going to learn all about this and we're going to look through this documentation. But this session is just to give you some background knowledge how to take a look at these new releases. So if we see here the summary of the changes, they talk, for example, we have changed the spelling of many of the standard library names. Exported circuits and constructor arguments are required to be disclosed. So this disclose, it's a protection that we have now in smart contracts to let the user, the developer, know, okay, I have something private, I'm disclosing that information because now it's going to appear on the ledger. So whenever that happens, you have to write disclose just to make sure that Compact knows that you are intentionally doing that and it's not a mistake. So this is a protection now, disclose. And the most important thing here about these changes, that they fix a failure to mint tokens. So there were a lot of people using the old versions of instances to test the minting of tokens, but now we can use testnet and actually the most updated releases to test the tokens features. We haven't got there. I mean, we want to learn through the process how to mint tokens and stuff. But yeah, now it's fixed. A new release. Also, it was regarding the language release. So we were talking about the Compact, but what about the release? Within this same release that I show you guys, if you go to the bottom, you're gonna see language changes. So here they explain how to write our code, not necessarily the logic, but the syntaxes, right? So it's like learning a new language. Here they say, okay, we have changed something on the language, so you're gonna have to write now your code in this way. It's pretty much like JavaScript. You have to learn the syntaxes of JavaScript to actually write code. The same thing for Compact. Excellent. And another release was the Midnight.js and the Indexer versions. These new releases, it's more just a patch for correcting some bugs before. But let's see what's going on with these releases. For the Midnight.js, we can see that the release, it just covered two features. One, they added this CAPTCHA header feature for faucet request, and they ensure segment number defaults to 0. So some releases, it's just patches. It doesn't affect too much our code, but we should upgrade to these new releases for protection and security. And the indexer, the same thing. We can see that they release this new version 2.13, and the changes included some refactor. They included some features, and they talk about compatibility, right? So yeah, that's something that we don't have to change anything on our code besides upgrading the libraries. So that's why it's important to take a look at the releases, just to make sure that our code keeps compatible with the new releases and update the code in case something happens. For example, for these releases of the Compact language, if we upgrade, actually our code is going to fail in case we brought something that it's not following these syntaxes anymore. Excellent. So now let's keep on going on where we left the last session. We were talking about the output of the circuit. So let's go to our code. And we learned the last session about the join contracts and deploy stuff. And then we run the increment circuit. And as an output, we had this finalized transaction data, where it's an object that covers all these outputs. We can see that we have some public stuff, we have effects, we have private information. So before going through these topics, I mentioned that we have to learn how the state and how transaction works within Midnight. So for that, I prepare a nice diagram and some pictures to illustrate how this works. So let's go to the state. Let's first understand how a state works in Midnight. So I mentioned that we have two states, the public state and the private state. The private state lives in the user machine or whatever database that the user has implemented, right? That doesn't have anything to do with the blockchain, and it can be under any shape at all. So that's why I'm representing here different squares where different users have their own private key, private state. I'm sorry. And then we have the public state. The public state, we have two protocols within the Midnight blockchain. We have the CSwap protocol and the Kashina protocol. So each one of those, it has its own shape of a state. CSwap, we can divide it in two big states. One, it's a Merkle tree where we have commitments, which are pretty much hashes. We learned just 10 minutes ago what a hash means. And then we have a set of nullifiers, where also a nullifier is a hash of a secret. You see how important it is to understand these concepts of hash? So we have this Merkle tree and we have nullifiers. And in Kashina, what we have, it's a map of addresses where each address has its own public data and some circuit references. So for example, for address, I mean one smart contract, we have a ledger state, public data, and circuits, we can have many of them. And each circuit has a circuit reference. So how this private state talks to the public state? It's through a transaction. How a transaction is structured? So we can see here that a transaction it's made by offers and transcripts. So we can say that we have a guaranteed offer, a fallible offer, an optional contract call or deploy, which are transcripts, and some cryptographic material, commitments and proof. So the important ones are the first three, offers and transcripts. People can ask me, what is the difference between guaranteed and fallible? That's something nice that we can actually write in Midnight, in Compact. We can declare different steps of our transaction. So if you see on the right, we have some flow for the execution of a transaction. First, we run the well-formedness of the transaction, where we check that everything is okay within the transaction itself. Then the node executes the guaranteed phase. And lastly, it executes the fallible phase. So what happens here? The nice thing about the fallible phase is that if this part fails, the transaction executes. If the guaranteed phase fails, then the transaction doesn't execute. So we can actually structure a transaction that we say, okay, this part, I want node to make sure that my transaction passes. But then I can also specify a fallible phase that I tell the node, if this part of my transaction fails, don't worry, just process my transaction, it's okay for me. So this is something nice that we can write in Midnight transactions. So now let's see how these offer and transcripts are structured. The offers, it's composed by these three things: a set of inputs, a set of outputs, and a set of transients. So that's why you've heard sometimes people saying, Midnight is kind of like UTXOs. So this concept of UTXOs comes from the sense that we can know what are the inputs and what are the outputs. But these inputs and outputs, what they really are these commitments that we just saw before, the CSwap state commitments. And then we have some transients. this process of transients, it's how we can pass from CSwap to Kashina. So we have coins here, but we can actually represent those coins into our smart contracts. So the way to represent and lock some commitments to actually represent that into a public state is through this set of transients. And the transcript, it's how we execute those smart contracts. And the transcript, it's composed by effects, gas, and program. Program, it's pretty much the execution logic that our node is gonna execute to change some state. The gas, it's the specification of how much our transaction is gonna cost. And the effect, it's everything that's gonna happen after executing our circuits regarding the blockchain itself. So we can, for example, if you execute some smart contract, then the effects could be something that happened on CSwap. So if we go back to our code, we can see that after the execution of the circuit, final last transaction data, we have public information regarding transaction. So this is the context of our transaction. We have public transaction hash. This is the hash of the transaction that was executed after running this increment. Then we have the transaction ID. We have the block height, right? So this was actually transmitted to the blockchain and our transaction was included in a block. So this is the block height of the block that actually our transaction was included. The block hash of that block. Then we have next contract state. What is this next contract state? If we relate that to our diagram, we can see that we have some state in our contract. After executing this transaction, a program is going to be executed and this state is going to change to something that we define under this program. So this is what this next contract state is about. Then we have our public transcript. What is public transcript? Public transcript, it's the program. Then we have the status, right, of the transaction. And then we have all this list of effects, right? And I have divided those effects in two. One regarding the guaranteed effects and the other one, the fallible effects. As I just showed you, the transaction execution can be divided in a guaranteed phase and a fallible phase. So here at the output of the transaction, they're saying, okay, this is the output of your guaranteed phase, and this is the output of your fallible phase. And each one of them, they have effects. And what we have inside the object of the effects? We have claim contracts, claim nullifiers, claim receives, claim spends. What it means, these claim things, right? At the end, these stuff are commitments. So claim nullifiers, if we look at the diagram, we can see that we have here a set of nullifiers in our CSwap. Nevertheless, we were talking about the Kashina smart contract. So when we execute something on our smart contract, we have effects that change something on the public state. And if we change something on the Merkle tree of the commitments, this is what they call a claim nullifiers. So our contract, it's claiming a nullifier. Our contract is claiming a receive. What is a receive? It's something that the contract received. And how this translates to this diagram. We have a commitment. At the end, we say that offer has some inputs and outputs. An input, it's a commitment that now this coin is going to pass from CSwap to Kashina. So this smart contract is going to be the owner of that token, of this input. So this is the way how we connect these two worlds, CSwap and Kashina. So we have claim spends. This receives would be the inputs and claim spends would be the outputs. We have mints, if our contract actually mints a token. We have the gas that we just show in the diagram. We have a gas on the transcript, and we have a program. We can see here, we have a program. And then they also specify our private information. What we have in the private information, we have what new coins our user is receiving on their CSwap wallet. What is the next private state? The same that happens for the public state, or we have a next state. On the private state, we also have a next private state. We have a next CSwap local state. The user, after executing this circuit, what has changed on their local CSwap state? We have the outputs. We have the private transcript output. So the transcript, it works as well for the private information. And then we have some unproven transactions. So this is for before actually have proven the transaction with the proof server. So see how this output of the circuit relates to this diagram. Everything in Midnight boils down to some state regarding private state, public state, and public state. It could be divided in CSwap and Kashina, and there is a way to connect these two worlds. So I hope the idea was clear. It's a lot of concepts, but you can go through these documentation and video again. We're going to publish this in YouTube. So, well, now, if anybody has any questions, you can raise your hands, and you can join the stage, and make any question at all. So we're opening for questions. You can raise your hands if anybody has any question. Okay, I'm gonna answer some questions that I got here, but still you can write any questions. I'm gonna keep looking at here at the chat. Somebody here internally was asking me, what is this part of the guaranteed and fallible phase in contract? They haven't seen.
Sorry, the raise hand is disabled.
Okay. I'm sorry. Yeah. Let's okay, we have it here. Okay, it's the raise hands are on. I'm just gonna respond that question that somebody made to me internally, but you can raise your hands, and I'm gonna let you join the stage in order. So I was saying, right? Somebody was asking me, what is the how can we implement this guaranteed phase and the fallible phase? So in Compact, let's open the documentation. This is a feature that I haven't used yet personally, but the last time I was looking at the documentation, and within Compact, if we go here in the documentation of contract, let's open here. We have the build section. And here we have reference documentation, and then we can see here that we have the Compact language. In here, we have everything about Compact. So if we go through the Compact reference, where was that? Ledger data types. Here, we have this checkpoint. So this checkpoint, it's how we can define what we want to be within the guaranteed phase and what we want to be a fallible phase. So we actually mark a checkpoint within our Compact code to let Compact know, okay, I want this to pass and I want this to optionally pass. It can be fallible. Okay, I'm gonna see who opened their hands. Anybody has any questions? Okay, Alberto. Okay, Alberto.
Hello.
Hello, Alberto.
Okay, I'm happy to be here, and I joined very late today. But I don't know if I can like shoot like any kind of question, or if
No,
it's
you
like a specific to the topic.
no, go ahead, Alberto. I mean, this is a Q&A. You can ask whatever question that you have. So it's okay.
Okay, so I've been trying to work into some kind of registry contract. And the main barrier that I have right now is that in this case we need the initial registration not to be confidential, right? So in the first time that I'm joining the contract, I'm disclaiming, hey, this is me, this is my address, and we're integrating with some off-chain features. So we are also pointing out like this is my email, right? So the main question that I have is there a way to obtain like the like in EVM we have like the message dot sender, right? So we have the address that is executing the logic in the contract, and I know we have here a function called own public key that
Mhm.
does allow us to get up like our own public key. But
Mhm.
how can I, if there is a way to match that with the midnight shielded address, because they are not the same, to make a like a comparison between them?
The, no, right now in Midnight we only have shielded addresses, right? And
Hmm.
the when you run that function, you actually get the address of the user executing that construct. But now we have maybe your confusion is regarding the shape of those addresses. That one could be
Hmm.
in under hexadecimal
Yeah.
code,
Hmm.
and the other one
Yeah,
it's using the base 32M, right? So
that's correct. Yeah.
you, I mean, independently which one you're using, they are the same in the sense that it corresponds to the same address, but you have
Yeah.
functions within Compact where you can encode and decode those addresses, right? If a function is outputting a hexadecimal code and you need the page 32, you can actually
Hmm.
encode it. And if you want to go
Encoded.
the other way, you can decode it, right? So you can play with both, and it's gonna depend a lot on the characteristic of the function that you want to run, right? So for
Hmm.
example, we are in the early stages of these libraries. So sometimes a
Yeah.
function that you might see are asking for hexadecimal type of
Hmm.
addresses. Another function might ask you, no, I want the base 32, right? So you have to make sure
Yeah.
to see, okay, what this function is asking me, and provide that type
Hmm.
of syntax. And you can play with these two different formats.
All right. All right. So in order to make like the comparison, you have to build in turn into bytes by decoding or encoding, and that way I can make a like a statement, right? Like this address, which is like midnight. I mean like mn dash shield. And I'm declaring that I'm accessible via this email. That's a way to do it, right?
Exactly, and the other way as well, Alberto. In case there is some features not available yet within Compact, you mentioned something about
Hmm.
off-chain, which is
Hmm.
really recommended, right? Because at the end, what you want to build your circuits are really lightweight, right? You don't want to
Yeah, correct.
include that much logic. So within
Hmm.
the circuits, you have these arguments that you can pass over. So all these really heavy computation and stuff, you can do it off-chain and just pass those results as arguments in case it's available, right? And in that
Yeah,
way, your circuits are going to be really lightweight, and it also works for those features that you want to implement. For example, oh, I don't have that in Compact. Don't worry. I
yeah.
mean, you can just read your wallet and then
Hmm.
update, right, the format of the address and pass that as an argument. So either way, it would work.
All right, all right. And one other quick question. I don't know if you're working with the, because I know you guys are working for the Mesh SDK that I have used a lot in the past too for other projects. Have you seen anything regarding like signatures? like message signature, like signing data and
Mhm.
verifying the signature, like for authentication.
Yeah, that feature, it's not available yet. It's coming. It's coming
Mhm.
really soon. I mean, they haven't released when they're gonna be included, but I guess that
Mhm.
for the next release, they're gonna include these signatures within Compact and also the unshielded addresses. So these two features, the unshielded, that is gonna allow the selective disclosure within CSwap, and
Mhm.
the digital
Yep.
signatures within the wallet to actually implement, because they want to integrate with Identus now. So all these features are going to have to
Mhm.
come really soon, but it's coming.
Okay. All right. All right. Thank you, then, Eric. That's the questions that I had.
Thank you, Alberto. Thank you for your questions. And
Oh,
well, anybody has any question? John, do you have any questions? Let's see here. I love seeing you windsurfing for fields. Let's see. John here has written some things. I love seeing you use windsurf. It's my favorite. Feel like VS Code. Yeah, John. I love windsurf right now. It's if we call here windsurf, I'm using a lot this new IDE. The reason that I was testing all these different IDEs, but I think I'm gonna stick with windsurf. Now they're gonna integrate with OpenAI, and what it's nice, it's giving you a lot of features for actually to have a lot of context when you're writing code. So these LLMs, they have some deadline regarding what they know, so you have to input a lot of context, and Windsurf has done a really nice job regarding how to provide that context. And since we are working blockchain, we know that information changes a lot, right? So it's really difficult to have the LLM train with the updated information. So they are doing some clever things how to integrate this context. So yeah, love Windsurf, John. And well, you have another question. It says, if you could figure out a way to collaborate with Windsurf to train a model, or use our Kappa AI model for accurate midnight and compact meshes coding in Windsurf, would be so amazing. I don't know how to connect the two other than referencing the midnight docs, but with that old information, it could be confusing for the LLMs. Yeah. Yo, what happened? There is a algorithm called RAC. Let's open here the here on Windsurf. For those that are not aware, they have this cascade thing that lets you input some context, right? And they have these two methods. They have docs and they have web. For docs, you can actually they can read this documentation, and this documentation is not like the LLM is trained, but they're using RAC. So they're reading the actually docs of these websites, and using RAC, they actually process in real time that information and input that as a context for the LLMs. Pretty much the way Kappa is working with the Midnight docs. So if for example, Midnight, we don't have the docs here. Midnight, we don't have the docs here. So if we don't have the docs, the other way they mention is using this web feature that lets you input any URL that you have. Nevertheless, you have to make sure that that information from that website, it's friendly with LLMs, and they're gonna use the RAC feature as well. So what would be easy to do, it's to make sure that this feature is working well for the Midnight docs, and in case it doesn't, we can talk with the Midnight documentation team to actually write those docs in a friendly way for LLMs. So in this way, we can use Windsurf with all the documentation updated, provided by the Midnight core team. John, you say, could you make a copy of your context for Midnight friendly docs for LLMs? Would be wonderful. Yeah. Actually, I'm gonna test during this week. If it's not the next session or next week, I can provide how compatible the Midnight docs are with Windsurf. and let you guys know. And at the same time, I'm gonna let the Midnight core team know as well if they have to change something on their docs. But yeah, John, yeah, that nowadays I really recommend using these LLMs. There's a lot of features. You don't need to rely everything with LLMs. You can actually code by yourself, but LLMs speed up the process, right? So yeah, Windsurf it's a really nice IDE that I started using like 2 weeks ago, 1 week and a half. Could you make a copy of your context for Midnight on a Google Docs and share it and update it as we go? Friendly docs, LLMs would be wonderful. Could you make a copy of? Yeah, for sure. The Windsurf, they have. You can at the end the docs, it's a URL, John, so you can just provide that as a web, and they also have this knowledge thing. I think this is not available for free plans. You have to have a pro plan. And what this knowledge is about, they provide that linkage for different platforms. For example, Google Docs, right? Google Drive, and everything that you have within Drive, your Windsurf knows everything about. So yeah. What these guys are doing, it's crazy, and it's gonna really lower the barriers for new developers. I have a subscription one for you have to use this knowledge. Then you can put all the information that you know, diagram, stuff like that on Drive, and Windsurf automatically it's not gonna know anything about that. Okay, perfect. So I think that's all for this session. And next session, we're gonna keep on investigating other APIs. And once we are done with those APIs, we're gonna start testing and seeing the logs, and then going through the UI. And after that, learning how to write more complex smart contracts. So we are just scratching the surface. There's a lot to learn in the time being and in the future, and we are in this ship together. So see you next session. See ya. Bye bye.